Hello and welcome to CEO's Projects. Today I'm going to show you how to take a PC power supply and make it so it can work with balance chargers or really anything that's 12 volts. To start off, you might ask, why do we even need to make a power supply out of a computer power supply? Well, one of the main reasons is that these power supplies, since they don't have any fans, they heat up very quickly, and once they get hot, they stay hot. And when you're charging something very large, like lithium polymer batteries, or really any battery, these things heat up very quickly, and so do these. And as you can see, there's only one plug on this. So, what I've done with power supplies like these is you harvest the 12 volt connections on the motherboard and the 5 volt or 3 volt connections that are also on here, and you can take them to power fans and power the motherboard because, for example, this thing, the 12 volt outputs that it has can do 17 or 11 volts at 12 or 11 amps at 12 volts, which means that this is, I mean, granted this is a 240 watt power supply, but that means on a single rail I can have 170 or 140 volts, which is absolutely perfect for something like this, which is an only 80 watt charger. And this charger also can take a variable input, so this can do 11 to 18 volts, which means that this is perfect for something like this. So, the way how we're going to start this is we're going to first make sure that this thing is powered down, which thankfully it has a button on the side, or on the back, which presses it and discharges everything on the inside, which they don't really have that nowadays. To find which rails are which on here, because we know which ones are the 12 volts and we know which ones are the 5 volts, but we don't know which one can do more current. We're going to use something like this. This is a female 24 pin motherboard connector. So what this does is this pops right onto here and it connects the two buttons, or the two lines right here. Every green line on a PC motherboard, or at least the green and the black wire, the green wire is to turn on the actual power supply. So when you take it and you short it using a switch, you can tell the power supply to turn on an output voltage even though it's not connected to a PC, which is also how some people daisy chain power supplies. It's not necessarily, it's perfectly fine to do so if it's just you're using it for 12 volts, but if you're daisy chaining it inside of a computer, there are much better ways to do it. So I'm gonna hook this up and we're gonna start doing some testing with the voltmeter. Thankfully, we know that on power supplies that are standard, this 4-pin or 8-pin connector sometimes will always have 12 volts because this powers the CPU and the fans, which means that we know for a fact that this runs on 12 volts because, well, they run on 12 volts. Now, thankfully, both of these run at an excess of 10 amps, which is perfect for an 80 watt power supply because, well, 12 times 10 is 120, so since these can both do more than 120 watts, we're perfectly fine. So what we're going to do is we're going to test both just to verify that nothing's wrong with this power supply, since this is an older power supply, and we're going to do that by using the switch. So as you can see with the light and the fan, it turns on. So it allows us to safely do that. Instead of jumping the wires, we have a full-on connection. So let's see. Will we get our wanted 12 volts? $11.8, so it's not exactly 12. And 11.8. So it's not exactly 12 volts, but thankfully in our case, this thing can still work at 11 volts. Most times the voltage will be closer to 12 volts. It's a little bit odd that it's 0.2 volts off, but when you're dealing with older power supplies, you get what you get. Beggars can't be choosers. So now that we have all this working, we're going to turn it off and unplug it. Now we're going to flip the switch just so that it discharges. You always got to make sure that it discharges, because if not, if I cut and solder and there happens to be a short, everything will spark and nobody will have a fun time. So, now that everything is discharged, I'm going to cut off the zip ties and the connectors and then solder the connectors to this, which actually, let's start this right now. We need this specific barrel plug due to the fact that, well, it plugs into the port on the power supply, on the charger. By the way, this is a balanced charger for LiPos. So we now have this. Now we're going to take them, we're going to strip them. Thankfully on the outside of this, it tells us the positive and negative of which terminal. So in other words, positive should be inside, negative should be outside. And sometimes the casing will always be the same, but the power might be different, or the polarity might be different. So you might have positive on the outside and negative on the inside, but the good thing with that is the wires still go to where they need to go, so you just have to change the color of the wires, or change which wire goes where. Oh, that came up beautifully. So the way we could test this is using our continuity function on our voltmeter. So we currently have positive. Now, if it registers on the outside, it means that we have outside positive, which means we have to then solder the positive to the negative. Okay, now let's test the inside. Okay, so this is showing that that positive is inside, which makes our life a lot easier because that means we could solder directly color to color. So now that we have all that done, we have this nicely stripped. We're going to just twist the wires. Going to move this out of the way. And since everything is disconnected, we are all safe to cut. Ooh, that just went flying. We're gonna take the zip tie off too, just because it makes our life a lot easier. Now, as you can see, there's a fan on this power supply, because this this charger. And the reason why is this charger just heats up. So what I also can do, since this is a 12-volt fan, is hijack the other route and make it so it works. But I'm sort of going to shy away from that because I do use a different charger with this. And actually, you know what? We'll do that still. But this doesn't require soldering because I made it so that the connectors come out. So now we have our 2 grounds and our 2 positives. So with that, what we're going to do is we're going to now take our positive and our 12 volts and our positive. We're going to spin them around all nice. And then we're going to take our soldering iron. Actually, you know what? No, first, let's solder each ground positive, because since it's discharged, I'm pretty much just soldering 2 wires together. Just so happens that they happen to be connected to a power supply. And I'm going to be using electrical tape to seal them up just because I don't have heat shrink, which I probably should buy some. So let's get this all nice and soldered. Now that we have the 2 things soldered, we're going to now wrap it up in electrical tape just to make sure that it does not short, because even while we're testing it, we don't want to short, because while these power supplies do have setbacks, they can still always cause a fire. We now have the ends soldered, and they're both a good few layers away from each other. So we're gonna plug that in. We're gonna plug this power supply in, and with this power supply plugged in, we'll be able to test it and make sure that this turns on. Because if not, then we got a problem. We have it plugged in, and we should see it turn on. There we go. We have success. So you can see how easy that was. We cut 2 wires, solder them to a barrel plug, and that's it. So now I have a power supply that's not going to heat up, that's going to be silent, and while it takes up some more space, it's overall a lot safer, because these types of power supplies can easily overheat, and since they're in a plastic housing, they can melt. So now that we got that done pretty quickly, we're now going to get this fan to work so that this still stays cold. Now thankfully, the wires that I used and the connections that I used were from crimp sets. The only thing is though, my crimp set is upstairs and I'm not gonna go grab it, so we're just gonna smush them. And now first we want to take these little housings and pop them on there, because with these housings it'll make it so that when the 2 crimps are together, I don't have to be afraid of them at all what do you call it? Smushing. I'm gonna get that in. And you know what? We're actually gonna be safe. We're gonna turn off the thing while we're working. I realized I should have done that a while back. So now we're just gonna continue smushing them. Now, due to the fact that I want this to be very safe, I'm also going to put a little bit of solder on the wires and the connectors. This will make it so that if I have to pull really hard, the connector is not going to come off, because that has happened a few times. And it's really just that easy. So now, ooh, that's very warm. So, now we're going to do it on the other one. We're going to repeat the same process. Sleeve. Come on. Sleeve, crimp, and solder. So now we have the sleeves on, and well, we're just waiting for that one to cool off because I almost burned myself. And once the sleeve is on that, we can just plug it straight in because we know which one's positive, which one's ground, and make sure that the fan works. And if that does work, then we're gonna charge this 6S 5000 milliamp hour, I think it is, or 3000. Forgot which one. I think it's actually 3000. And yeah, and that's it. All right, let's test it. The fan works. I don't know if you can actually see it, but the fan is spinning, so we do have success. So now we have a fan in this power supply and a fan on this, which means that the next thing we need to do is actually charge a battery to make sure that this does work. So let's take this. Okay then. It just turned off. Let's turn it back on. You know what? For safety, since I do have to move some stuff around, I'm going to wrap this up in tape. Good. Normally I have it exposed because I have them using different types of connectors, but let's just be safe. So, it's not making noise. The fan got caught off on it. So we take the positive to positive, negative to negative. We plug in this. Now I'm fairly sure this thing is fully charged, but it's always safe to keep your batteries nice and charged. And this particular connector is this particular charger can do up to 6S batteries and pretty much any other type of battery, which is absolutely awesome. So let's put this up to the max current possible, 6 amps, which this thing won't charge at 6 amps just because of the total wattage. It literally can't. So alright, so there we go. You can see right there, it is in fact charging. It's currently charging at 2 amps, 24 volts. Now that's just because, well, this is rated for 80 watts, but it doesn't mean it's going to use that 80 watts. I found that out very, very quickly. But also it makes sense. If I'm doing 25 volts, the most I can do is about 50 and a little bit, so that's like what, like 2.5 watts or 2.5 amps if I'm doing 25.2 volts. So I mean, that was quick math, but that's definitely wrong. But overall, as you can see, it works. And now I could easily go and work on something else and say, okay, this is not going to heat up. I'm not afraid about that. This is not going to heat up, so I'm not afraid about that. And this is a very expensive, I think it was like $60 to $70 charger. So this isn't going to heat, this isn't going to explode. This might heat up and melt. Let's turn that off, actually. And that's it. So, and another thing is also, since this does so much, I can take the stuff that comes out of this and I can use it for other stuff. Or I can charge multiple batteries at the same time, as long as the amperage is not messing around, or as long as the wattage is not too crazy. So, because one of these wires can do 110 volts max, or 110 volts maximum, and the other one can do 170 watts maximum. I hope I said watts for that one. And so what that means is I can charge one thing on one side and the other thing on the other side. And since this has a fan built in, it's never gonna get warm. And if it does get a little bit warm, then I'm still fine. So this is gonna charge, as you can see. It might take a little while, I don't know. But overall, I consider this a success, and it shows how easy you yourself can do it. So thank you so much for watching. This is actually the first video I'm trying a second angle to show the type of soldering and stuff that I do. I really hope you enjoy it, and I'll see you in the next video, next Sunday, 8 a.m., as per usual. Bye.